This is the recording for completing the Investigating Single and Double Displacement Reactions. The link to the website can be found right under Reference Website. This is the website you should use to complete the entire lab. If you have an issue getting it to open up, please let me know. And one of my suggestions for that is to always try another browser first. Usually that's the issue. If you're having problems opening a link, you can sometimes just use a different browser and that will help. Here's a brief description of the activity. This activity will cover single displacement reactions and double displacement reactions, which we talked about at the end of last week. So here's some background information on that if you want to read up on it. Hypothesis, you be sure to just type your answer right here. If chemical reactions occur that I expect to observe, and just list what you would expect to observe right here. You really can't get this wrong. This is a hypothesis, so just take an educated guess. There are two pre-lab questions with this lab. Number 1, define precipitate, and number 2, define activity series. You can just list your descriptions right here of those. Here's the same link as before. It's up at the top just for your convenience. You can also click on it right here. So open this website, and when you open it, it should look like this. So this is a picture of the screen you should get. So what you want to do is click on each of the chemicals from the bottom and the metal ions from the top as indicated by table 1. So the very first one you're doing is magnesium turnings and Ti+3. Magnesium turnings say Mg turnings, click on them. Ti+3 is right up here. And when you have those both selected, you will click on Play Movie. And just watch what's happening. So you're adding in the magnesium turnings, and immediately I notice bubbling. Bubbling means that a gas is evolving, so you're having gas come out. And I'm also noticing a color change from clear to dark brown. So that is actually what you would record. So it says right here, once both elements have been clicked, they will move to the left portion of the screen above the buttons, Play Movie and Reset. So we clicked on Play Movie, we watched it, and we want to record our observations in Table 1. I believe I've already done that for you. So whenever you mix the magnesium turnings with the Ti+3, you observe bubbling, which is a gas, color change from clear to dark brown. And then you'll want to do the same thing with magnesium turnings and Fe+3. So what does that look like? Click Reset, click on magnesium turnings, Fe+3, and then Play Movie. You watch the movie and record your observations. So here I again see a lot of bubbling. I see a color change as well. So that is what you record right here under Fe, magnesium turnings. Do the same thing for copper and zinc, and then do the same thing, but instead of with magnesium turnings, you're using zinc granules and titanium+3. Iron +3, copper +2, and zinc +2. And so all you're recording here is just whatever you observe. If you observe bubbling, that means a gas. Any sort of color change, anything that you observe goes in this table right here. Now you're going to do the exact same thing for part 2. So combine the aqueous salt solutions in the same way as you did above according to table 2. And then these are just in the table what you're going to do. They're kind of just for your information. You don't really need to do anything with this right here. So you'll combine them, then you'll click Play Movie. You'll record your observations in table 2, and you will also write the name and correct formula of the compound that you believe to be the precipitating product of the reaction. You can use the solubility rules to help you determine which compound has precipitated. So let's move down to table 2. So how do we do table 2? Well, same thing as we did before, except now we're using sodium hydroxide and iron 3 chloride. So back over to our thing, we were using sodium hydroxide, that's this right here, says sodium hydroxide, you're not going to find FeCl3 on here. Instead, you're just going to use Fe plus 3. How did I know to use Fe plus 3? Well, it's iron 3 chloride. That means that that's iron 3, iron with a charge of plus 3. So for like copper 2 nitrate, you'll want to use copper plus 2. For zinc 2 sulfate, you'll want to use zinc plus 2. For cobalt 2 chloride, cobalt plus 2. Nickel 2 iodide, nickel plus 2. Alright, so once you combine those, then you want to click Play Movie. And you'll just record your observations just like you did before. And your observations for this one are a little more directed, so you would want to write the name of the precipitate. So what is going to be the precipitate here? Well, it's going to be iron 3 hydroxide. You'll want to write the formula, that's FeOH3, and you'll want to write the color of the precipitate. So what color is the precipitate or solid going to be? To determine which one is going to be the solid, you need to use your solubility rules. So scroll up, they're right here. They're also in your notes as well. So you're looking for the one that comes up as insoluble. So I believe down here it was FeOH3, so iron hydroxide. So you're looking for the hydroxides, that's this OH minus, and they are all insoluble, meaning they will be a solid, which is a precipitate. There are some exceptions, but iron is not one of them. So iron hydroxide will be a solid. So that's your precipitate here. If you're wondering how I got this FeOH3, basically what you do, you have FeCl3 and you're combining it with NaOH. This is a double displacement reaction. The sodium and the iron are going to switch places, so you'll end up with NaCl and you'll end up with FeOH3. NaCl will be, if you look up at your solubility rules right here, you look for the anion, that's Cl minus. Everything's soluble in it except these things right here. Sodium chloride, sodium would not be an exception, so sodium chloride would be soluble. That would mean it would be dissolved right into the solution. So then you'll just do the same thing for FeCl3. Again, you're using iron 3 and combining it instead of with sodium hydroxide with sodium carbonate. Let's look at what that looks like. So here's sodium. Oh, here it is right here, sodium carbonate. So we were doing sodium carbonate and Fe plus 3. And then you just play movie and write your observations. And then you have a few data and analysis questions and conclusions. So you'll want to use your observations to determine whether magnesium or zinc is more reactive. Just think about the reactions that you watched involving magnesium versus the reactions that you watched involving zinc. And then for these, you're just giving the general color. So when you're using iron, what color do you see? When you're using copper, what color do you see? When you're using zinc, what color do you see? And when you're using nickel, what color do you see? So that's up here. So take a look at what color these precipitates are, and that's what you want to fill in here. All right, that's it. If you guys have any questions, do not hesitate to ask me in class or send me an email. I'm here to help you.